In this experiment, I'm going to manipulate the forces which are acting on the mass which is sitting on that balance. Right now, the balance reads 9.80 newtons, which means that the weight of that object is 9.80 newtons. The number of forces acting on that object are two: the downward force of gravity and the upward force, the normal force, provided by the top surface of the balance. That's pushing the object up, and for that reason, the two forces cancel each other out and the object is not moving, it's stationary. If I was to take a string, what I could do is I can pull upward like that, and I can support the object with the string. Now, since I know the object weighs 9.80 newtons, in this case we have two forces acting on that object: downward force of gravity, upward force of the string. I know the tension in the string is 9.80 newtons. I'm going to lower that, detach the string, still 9.80 newtons. I'm going to reattach the string, pass it over the pulley. Looks like the string has no effect on the reading of the balance. Now what I'm going to do is I'm going to take this 10-gram mass and suspend it in that fashion. And we see that the reading on the balance is 9.70. Now remember, the balance provides us a measurement of the force, the upward force acting on the mass which is sitting on the balance. The mass now has three forces acting on it. We have the downward force of weight, the upward force of the string, and the upward force of the balance. The upward force of the balance is 9.70. The downward force due to gravity is 9.80. So that must mean that this force, the tension in the string, which goes all the way around, is provided by this object. So this object here must be providing a force of 0.10 newtons. Let's replace that weight with a 20-gram mass. And we now have a reading of 9.60 newtons. So that means that the upward force provided by the balance, 9.60 newtons. The downward force is 9.80 newtons, which means that this force in the string provided by that mass is 0.20 newtons. So the weight of that mass must be 0.20 newtons. And if you take 20 grams and multiply it by 9.8, you're going to get close to that force. If we now take a 50-gram mass, you guys can predict what to expect. Make your prediction. Oops. It's all falling apart. Okay, better. Let go. And what do we get? 9.32 newtons provided by the balance. Downward force of the mass, or the downward force acting on the mass, is 9.80. Upward force provided by the string plus the upward force, 9.320, should equal to 9.80.